Hello dear students, this is Mr. Muhammed Azeez. In the previous video we solved this question, and in this video we're going to continue on chapter 4 section 3. Here we have some limits of trigonometric functions at positive or negative infinity. Firstly, we have an example. Limit x tends to positive infinity sine x. If I replace x with infinity, I'm going to get sine infinity. Sine infinity does not exist because it is oscillating. Sine infinity, cosine infinity, if they are completely alone like this, the limit does not exist. But if sine, cosine of infinity is into some sort of calculation, then the limit might exist. Look at this. Step 1 for every limit question is to replace infinity. I'm going to get sine infinity here and over infinity. As you know, sine is a wave function. Sine is a wave function. It is between -1 and 1. That means sine of infinity is not equal to infinity, and it's not equal to 0. It is some sort of oscillation which is between -1 and 1. But this time the oscillation is not alone. The -1, 1 is not alone. It's divided by infinity. As a fast way, instead of sine infinity, I can always write +1 over infinity. -1 divided by infinity is 0. +1 divided by infinity is 0. Result is 0. The answer of this limit is 0. That's it. Do not mix this with the special limit of chapter 2. In chapter 2, sine x over x will be 1 if the limit tends to 0, not infinity. Remember this. In Uzari, there have been questions like sine x over x, which looks like the special limit of chapter 2. But remember, special limit of chapter 2 will be equal to 1 only if the limit tends to 0, not infinity or pi. We can also use sandwich theorem. Sandwich theorem or squeeze theorem always works for limit x tends to infinity and the trigonometric functions, especially when sine and cosine are into calculations. Now let's do the same question, avoiding the fast way. By the way, this fast way works like a champ, it has no problem. Always sine infinity, cosine infinity. If they are into some other calculations, we can just consider them positive -1. Now let's solve this limit using sandwich theorem. Sandwich theorem, we always begin with the trigonometric part. Sine x is located between 1 and -1. Now in order to recreate this function, I need to divide by x. If I divide this sine by x, I will get the function. So divide everything by x. Divide by x. This is how sandwich theorem works. I need to recreate this function. This side will be -1 over x less than equal to sine x over x less than equal to 1 over x. Now, instead of working on this function directly, which is this function, I work on the side functions. Now for this side, limit x tends to infinity, just like the question, for -1 over x. The result will be -1 over infinity, that is 0. Number over infinity is 0, and 0 does not have sign to be -0. For the other side, limit x tends to infinity for 1 over x, and obviously this one is also 0. Now since left limit is equal to right limit, since left is equal to right, the limit of this function is also 0. We got the same answer. Sandwich theorem is also a good way. Now let's solve more questions in this section. Here I wrote you the limits. The limits on this side that are approaching 0, these are chapter 2 limits, and these are chapter 4 limits. These are the most common questions in Wizari and in the book exercises. Sin x over x when x tends to 0. You know it will be 0 over 0, so we can use L'Hopital, result will be 1. Or you can memorize this as a rule, that's a special limit. Result is 1. If we flip it, x over sine x, it's the same, result will be 1. Cosine x over x does not exist, because if we replace cosine with 0, cosine 0 is 1. 1 over 0 is undefined, and for limit, undefined means does not exist, or infinity. Infinity also does not exist. This one will be 0 over 1, result is 0. Sine 1 over x, if we put 0, that will be sine infinity, and sine infinity alone does not exist. Similarly for the cosine. And for these, we just solved this one. This one does not exist. Infinity divided by positive negative 1. The result is not stable. The result, we don't know if it's positive infinity or negative infinity. Since we cannot make the decision, does not exist. Or we can use sandwich theorem, and you will see one side will be negative infinity, the other side will be positive infinity. So left won't be equal to right. For the rest, it's the same. Let's solve this. Cosine x. As I said previously, cosine infinity, if it's not into any calculation, if it's alone, that's just does not exist. And this one we can use sandwich theorem. As you see, the answer is not available. You can write what do we write right now? Cosine x is between 1 and negative 1. Now divide all of them by x, negative 1 over x less than equal to cosine x over x less than equal to 1 over x. Now take limit x tends to infinity for all the three. For the left side, it will be 0. Limit x tends to infinity cosine x over x less than equal to, and if we put infinity here, we'll get 0. Now since left is equal to right, this limit is also equal to 0. What if we use the fast way? If we use the fast way, we're going to replace infinity with the x. We're going to get cosine infinity, that's the fast way, over infinity. Now since cosine infinity is not alone, it's with another infinity here, replace the cosine infinity with positive negative 1 over infinity. Now negative 1 divided infinity is 0. Positive 1 divided infinity is also 0. Final answer is 0. Both ways work. Now we have more questions. Here, if we input negative infinity, this is the case where L'Hopital fails and result will be negative infinity over positive infinity. And since L'Hopital fails, limit x tends to infinity and there is x squared in the radical, we can just use the fast way. Coefficient of this x is 1. Coefficient of this x is radical 1, which is also 1. Add a negative because the limit is negative infinity. Final answer is negative 1. For this one, put infinity, that is going to be 1 over infinity, which is 0. Cosine 0 is 1. Sine 2x over x, when we replace x with infinity, result will be positive negative 1 over infinity, that's 0. And this one, in Wizari exam, this type is very, very common, including last year, 2025. In the first and the second attempts, there have been questions like x tends to infinity for some sort of fraction containing trigonometry. Now I want to show you two ways to solve this question. One of them is sandwich theorem or squeeze theorem. The other one is divide everything by x. Now, if we use the fast way, replace x with infinity, I'm going to get 1 over 2 times infinity is infinity plus sine infinity. Sine infinity we can just replace it with positive negative 1. 1 over infinity plus positive negative 1. Infinity plus 1, infinity minus 1 is the same, it's just infinity. In both cases it will be infinity positive. 1 over infinity is 0. The result of this limit is 0. Let's solve the same question using sandwich theorem, which is a very scientific way. We always begin with the trigonometric path because I'm sure sine x is between 1 and negative 1. Now to recreate this 2x plus sine x, I'm going to say add 2x to all of them. All of them plus 2x. That's going to be 2x minus 1 less than equal to 2x plus sine x less than equal to 2x plus 1. Now I added 2x. What did I make so far is 2x plus sine x, which is the denominator. Now I need 1 over 2x plus sine x. Then I say flip. Flip all of them. This is over 1. This is also over 1. This is over 1. Over 1 is always available. Now when we flip, we actually flip all of them and flip the inequality signs as well. There. 1 over 2x minus 1 greater than equal to 1 over 2x plus sine x, that's the function we have, greater than 1 over 2x plus 1. Now we take limit for left and right function, x tends to infinity. Now here if we put infinity, that's going to be 1 over 2 times infinity is infinity, minus 1 is infinity, greater than equal to the function. We don't work on the function directly, we only work on the side functions. This is how sandwich theorem works. And here if we put infinity in place of x, 2 times infinity plus 1 is still infinity. Now this side becomes 0, the side becomes 0, which means limit x tends to infinity, 1 over 2x plus sine x is equal to 0. So I got the same answer as the fast way. This way is sandwich theorem, this is the fast way. And if you see limit x tends to infinity and result is infinity over infinity, we are allowed in this case to divide every single term by x. That's also a very efficient way, especially when L'Hopital fails or when L'Hopital does not make the limit any easier. We have examples. Question 16 is a great question. This question is amazing. Question 16. F is a continuous function such that limit x tends to infinity fx equal to 5. So since limit x tends to infinity for f is 5, that means y equal to 5 is horizontal asymptote. Now the question is asking for find, if possible, limit x tends to negative infinity. So we need to find the left side of the graph as the right side approaches 5 in each of the following cases. A, if the function is symmetric with respect to y-axis, which means even. If a function is even, when the right side, this is the even case, when the right side approaches 5, left side must approach 5 as well, so the function stays even. So y-axis cuts the graph to two identical pieces. So to keep the function symmetric, when right side approaches 5 according to the given, left side must approach 5 as well if the function is even. Now based on this fact of even function, I can find limit x tends to negative infinity for fx is also 5. Why? Because f is even in this case. Secondly, if the function is symmetric with respect to the origin, which means odd function is usually like an S or N shape. Now, I'm sure on the right side the graph approaches 5 because it's given here. Limit x tends to infinity, positive, is 5. That means on the right side the curve approaches 5. Since the function is odd, whenever on the right side a curve is up, the same shape, same curve should be down on the left side and vice versa. Now, since this right side goes to positive 5, then the left side must approach negative 5. Now, based on this fact of odd function, I can write limit x tends to negative infinity fx equal to negative 5. This idea have been in Uzari a lot. Now we have 6 functions to match with 6 graphs. Matching functions to graphs, point plotting is the best way. Now here, this graph, if I calculate f of 0, that's going to be 2 plus 0, which is 2, over 1, result is 2. It means if I put 0 in place of x, I will get 2. Look at the graph. When x is 0, y is 2. This is the point. This point 0, 2 is on this graph. That means this graph belongs to 17. 0, 2 is not on this graph. It's not on this graph. It's not on the other graphs. Not here, not here. So the only graph that has 0, 2 must be the graph of 17. Now 18, if I put 0 in place of x, I will get 0 because it will be 0 over negative 4. So number 18, if I put 0 in place of x, I'll get 0. Point 0, 0 is here, but only using 0, 0 I cannot make the decision because there's another graph on 0, 0. Okay, then let's try something else. Let's put 3 in place of x. If I put 3 in place of x, or I can also find the vertical asymptote, what makes this denominator 0? 2 and negative 2. See, 2 and negative 2 are vertical asymptotes. So I know this graph, number 18, belongs to this graph. Number 19, as well, this graph belongs to number 19. Only 21 does not have graph. See, if a graph does not belong to a function, how is it? If I put 0 in place of x in this function, it's undefined. Add 0, yeah, it is undefined. There is no graph. But that's not enough. Let's put another number in place of x. If I put 1 in place of x, what will I get? Put 1 in place of x. 3 plus 2 over 1. That's equal to 5. Always when you calculate, change the calculation to point form. I put 1 in place of x and I got 5. The 0.15 is here. It's not on the graph. That means this graph does not belong to 21. But the other 5 graphs are matching. And I put this example here to show you when a graph does not belong to a function, you will easily find a point that's not on the curve. And that's enough to say this graph does not belong to this function. In section 4, we do need this idea a lot. The whole section 4 is about matching curves to functions. Here we have 2 true-false questions. If f prime is greater than 0, so whenever f prime is greater than 0 means f prime is positive, then f is increasing. But since f is increasing, it doesn't mean that increasing is always going up without bound. Without bound means the curve is going up forever. There are some cases where the function is increasing, like this example. This f is increasing, but it's not going up forever without bound. It will never exceed 0. There's no any graph above 0. 24 says if f prime is negative, then f is decreasing. That's true, but when they say without bound, this makes the expression false. Without bound means the curve is going down forever until negative infinity, while it's not. This function is decreasing always. It is decreasing forever, but again, it will not exceed 0. There is no any graph for this function below 0. It keeps going and it keeps getting closer to 0. It will never exceed 0. This is why whenever you see without bound for increase or decrease, that's not always true. And since it's not always true, it will be false. Now partial test, the end of chapter 4. No, that's not end of chapter 4, that's partial test. Alright, now we have partial test. These questions are very ordinary. We just solve same idea for all of them a lot. For this question there is a mistake. We can correct it. If you see x, not x, sine x, cosine x multiplied. If you see two trigonometric functions multiplied and result is 0, no need to do divide cosine. Okay, these are not right. Correct it. Whenever you see two trigonometric functions multiplied, we can just solve each one separately to find 0. Sine x equal to 0, and it is between 0 and pi over 2. That's between negative pi over 2 and pi. Okay, the only value that makes sine 0 is 0, x equal to 0. And what makes cosine 0? Cosine will be 0 at negative 90 and positive 90, which means positive negative pi over 2. Positive negative pi over 2 cannot be criticals because they are the beginning and the end of the interval. These cannot be critical. So the only critical we have is x equal to 0. Then we take second derivative and put 0 in place of x. The result gets positive. Since the result is positive, f double prime is positive. F double prime is positive, that means f is concave. Whenever f is concave, that means the critical value in this region is minimum. This is why the point 0, 0 is minimum. Only remove these, write these instead. And write this as a note. Negative pi over 2, positive pi over 2 cannot be criticals because they are the end and the beginning of the interval. An amazing question. This question at the partial test is amazing. There have been a lot of Wizari questions with the same idea of this question. Now we're going to solve this one properly on the notebook. This is a great question. Okay, let's begin. Find the value of a, b, c, knowing that the graph of the function fx is given has a point of inflection. That's a keyword. Point of inflection at x equal to negative 1. Point of inflection at x equal to negative 1. This is telling us f double prime of negative 1 equal to 0. Why? Because negative 1 is inflection, and inflection makes double prime 0. That's one piece of evidence. And here, tangent line of the equation. Okay, equation of tangent is given. So whenever you see tangent given, that means slope equal to derivative. Tangent means f prime of what value? Since it says at that point. At that point, so some point must be given before that. Yeah, a point is given at x equal to -1. So tangent is this at that point. At that point means x equal to -1. So f prime -1 equal to slope of tangent. Slope of tangent, according to this given, it's -3. Slope of tangent is -3. So that is the given f prime -1 equal to -3. That's given. These are two givens. Alright, let's begin. Let's work on f double prime first. F double prime, I just need to find the second derivative for this function. F prime x equal to 3ax power 2. Now you might wonder why we work on f double prime first. You know, this cubic function, if we take derivative twice, it will be linear, and dealing with linear is easier than dealing with quadratic, which is f prime. So 3 goes down, 3 times a, 3a, x power 2 plus 2bx, and c is a constant, derivative of c is 0. Gone. Alright, f double prime, 2 goes down, 6ax plus 2b. That is the second derivative. What I know about second derivative is if I replace x with -1, I'll get 0. So 6 times -1 is -6a. I replaced x with -1, so 6a times -1 is -6a plus 2b equal to 0. If we don't have equal to something, that's not equation, and it will be useless. Now I found a relation between a and b. Let's make b the subject. B equal to -6a goes to the other side, becomes +6a. That's 2b. So to remove the 2, divide by 2. Now b is equal to 3a. That's one relation between a and b, which we need for later. Now I'm going to work on f prime. F prime -1. This is f prime. Replace x with -1. -1 power 2 is just 1 times 3a. That's 3a plus 2b times -1 will be -2b equal to -3. It's given. Now I'm going to replace b with 3a. b will be replaced with 3a because that's what we found in the previous equation. 3a minus 2 times 3a equal to -3. 3a minus 6a equal to -3. -3a equal to -3. a equal to 1. If a is equal to 1, then replace a with 1, b equal to 3. I found a and b. Now I'm going to use a and b and -1 to find c. Since c is in f, remember this, we can always work on f if we have a point given. Point consists of x and y. The x is given, -1, but the y is not given. Is there any way to find y? Yes, of course. Y is right here. It's tangent. You know, tangent and curve intersect at x equal to -1. And if two functions intersect, at the point of intersection, they are equal. Simply, we can just say this is the only y given in the question. Use it to find y. Replace x with -3, y equal to -3 times -1 minus 1. -3 times -1 is +3. +3 minus 1, y equal to 2. So when x is -1, y is 2. Now I can use this point in f because we know it's x and we know it's y. Let's start replacing. 2 is y, it's the result. A is 1, b is 3. Instead of a, I can write 1. Instead of x, -1 power 3 plus b is 3, this b. -1 power 2 plus c, the only unknown, equal to result 2. The only unknown in this equation is c. Now we can easily find c. -1 power 3 is still -1 times 1 is -1 plus -1 power 2 is +1 times 3, that's 3, plus c equal to 2. Now -1 plus 3 is 2, 2 plus c equal to 2, 2 goes to the other side, c equal to 0. Now I found the value of a, I found the value of b, I found the value of c as well. That's a great question. Now you can see all the answer together. Let's go back to the book. If the statement is true, prove it, and if it is false, give a counter example. The point 10, reading this, the point 10 is the point 10 is a point of inflection of the graph of the function x minus 1 power 4. We had a note about bracket power 4. Bracket power 4 is the only function where double derivative is equal to 0 if double prime 1 is equal to 0, but it's not inflection. So that's false. This function does not have any point of inflection. Its graph is a U-shape. Here is the point, x equal to 1, y equal to 0. This is not point of inflection, obviously. It is critical. The critical is minimum. The function is always concave, but it does not have inflection. All right. Part B, if double prime c is greater than 0. Okay, double prime c greater than 0. Simply it's telling us if double prime of a certain value is positive, which makes f concave. Okay, then the slope of the tangent line of the graph of the function is positive. No, slope has nothing to do with f double prime. F double prime positive is telling me f is concave. And if f is concave, slope is not always positive. Look at this concave graph. On the side slope is negative, the line is decreasing. On the side slope is positive, the line is increasing. So whenever we have f double prime positive or negative, we cannot make any decision about the sign of slope. We cannot say since f double prime is positive, then slope is also positive. No. F double prime is positive, has one job, f is concave. And if a function is concave, obviously half of it has negative slope because the tangent lines are decreasing from left to right. The other half are having positive slope because their tangent lines are going up from left to right. So both true-false expressions are false. And here are examples. More questions about limit. This question C is a very, very good question. Limit x tends to infinity. And if we replace x with infinity, this is infinity power 2, it will be positive. And that's infinity minus 2 is negative infinity. With absolute, it will be infinity over infinity. Since it's infinity over infinity, there is a way. There are two ways actually, but one of them is the best, which is, since there is absolute, El Hospital doesn't work. Cancelling does not guarantee. Change this to two brackets, there is a 2. Making two brackets takes time. Then what we do? Divide everything by x. When are we allowed to divide everything by x? If the limit x tends to positive or negative infinity, and if after we input the infinity we get infinity over infinity. Positive, negative sign of the infinity doesn't matter. We will get something that we cannot decide. We don't know if the limit exists or does not exist. We get infinity over infinity. Then what we do? Just divide everything by x and simplify. Here, why did I divide by negative x? Because x tends to negative infinity. These x's are going to be placed with a negative number. So we divide everything by negative infinity. If this infinity is negative, then we divide everything by negative x. 2x squared divided by negative x, we can simplify it, it will be negative 2x. X over x will be 1, negative negative will be plus, negative negative will be positive, 1 over x is remaining here. This will be negative 1 plus 2 over x. This time replace every x with negative infinity. We're going to get negative 2 times negative infinity, that's positive, plus 1. 1 over infinity is 0, and here final answer will be 0, and here is negative 1 inside absolute positive 1. Infinity over positive 1, the result is positive infinity. So the result of this limit is positive infinity. This one is also a very good question. There have been questions like this in Wizari. We're going to answer or complete the table by using only plus, minus, 0. Nothing else. Now, we work on f. F is on the graph. The graph is f. The question is telling us this given graph is f. Now, since I know the graph of f, to answer these, I just use the graph. If x is negative 2, what's the value of y? It is positive 2. And the question said only answer by the sign. It will be positive 2, the 2 doesn't matter, the positive sign. F of 0, when x is 0, y is also 0. F of 3, when x is 3, y is positive 2, so it is positive. Negative 3, when x is negative 3, y is negative 2, and we need only the sign. 4, when x is 4, y is 3, we need the sign. The first column is complete using the curve. Second column is about f prime. So I'm going to answer f prime by looking at the graph and see. Whenever the graph is increasing, f prime is positive. Whenever the graph is decreasing, f prime is negative. Negative 2. Negative 2 is maximum. At maximum, derivative is 0. 0. 0 is minimum. At minimum, derivative is also 0. 3. 3 is a critical. It is not maximum or minimum. Since it's horizontal tangent, then again derivative is 0. It is critical, but it's not maximum or minimum. It's just critical. Negative 3. Negative 3 is in a region where the graph is increasing, so it's positive. 4. 4 is in a region where the graph is increasing. That's positive as well. Increasing, positive, increasing, positive. Double prime. We can make decision about double prime by looking at concave, convex. Concave will be positive, convex will be negative, and inflection between them will be 0. F double prime, -2. -2 is in a region that is convex. Convex is negative. 0. 0 is in a region that is concave, and concave is positive. 3. 3 is point of inflection. Why? Because this side is convex, this side is concave. 3 is between them, so 3 is inflection. It will be 0. -3. -3 is in this region where the graph is convex. At -3, this piece of the curve is a part of the convex region. Negative. 4 is in a region that is concave. See, 4 is in the concave region, which is positive. There is a Wazari question. Same idea. At the end of chapter 4, I think it's question 10 in the Wazari questions. Now go to the end of chapter 4. Yeah, there, question 10. This is a Wazari question. Same idea of the question we just solved. Now, we have 4 tables given. We have 1 graph given. The graph is actually the same as the one we just solved. Now let's find which table is correct. F -2. F -2 is positive. That's true. Now if I look at F -2 in this graph, in this table, it says negative. That's false. So because of this, which is not right, B is out. Each of C and D, they have F -2 positive, F -2 positive. Now, F0 is 0 for all of them, so I don't even look at it because I cannot make decision. It is 0 for all 3. Now F of 3 is positive. F of 3 is actually positive too, so it is positive, that's right. F of 3, table C says positive, that's also right. Table D says F of 3 negative, that's false. So because of this negative, D is out. Now we have A and C in the competition. Let's move to the second column. Second column is not good as well because 0, 0, 0, 0, 0, 0, we cannot make any decision as all the results are 0. No difference. The last column, it's about F double prime. This is negative, this is positive. We can find which one is correct. -2 is in a region that is convex, and convex must be negative, while table C says positive. That's false because of this positive. More, 0, F double prime positive. That means 0 is in a region that's concave. True. This one is also false. 3 is point of inflection, F double prime is 0. That's correct. Now we can tell A is the correct answer. Now let's go back. One question left, and then this video finishes. Next lesson we will start on 4.4. Yeah, this question. The point of inflection for fx equal to x squared plus 1 over x. Alright, to find point of inflection, we need to find second derivative equals 0. To avoid using quotient rule a lot, I can just use partitioning. Fx equal to x squared over x plus 1 over x. Since the denominator is only one term, we can always apply partitioning to make the function simpler and easier to deal with. There is simplifying, it's still fx, not f prime, x squared over x is just x plus 1 over x. Now find derivative. F prime x, the derivative is very easy now after doing the partitioning. Derivative of x is 1. Derivative of 1 over x is negative 1 over x squared. That's f prime. We need inflection, so we need f double prime. F double prime, derivative of 1 is 0, just goes away. Negative 1 over x squared becomes 1 over x power 3. Not 1. 1 times 2. Multiply the power. 1 times 2. The 1 is negative, the 2 is also negative. The negatives cancel out. So I got 2 over x power 3. 2 over x power 3 is the second derivative. That's not equal to 0. If we replace x with any number, we never get 0. So that's obviously telling us 1, 2 is not inflection. It can't be. Negative 1, negative 2. Surely, if we replace x with negative 1, we won't get 0. And same thing here. So the result will be none. Thank you so much for watching. This is the end of this session. Next lesson we will start 4.4. Thank you for watching. See you soon.